Okay, greetings one and all, and welcome to this has to be day number 4, yes, day number 4, week 2, fall 2020, well, spring 2025 of our journey together. And it's definitely a delight to have each and every one of you here for this evening's classes. Let's begin. So we have, we're going to be doing science first. Urban social studies, just going to be doing some past paper questions today. And so all of the things I give you is going to be based off of some past paper questions. We're just going to be going over some questions that they had in your previous exam. All right, so let's go ahead and do this. So let's start off with the sun. So it's number 1. So what do we know about the sun? The sun is a what? Is the sun, what do you know about the sun?
It's a really big star.
It's super hot.
Very good. So the sun is,
Oh, and also, if the sun was too far or too close, then the world would be out of balance.
very good. So the sun is the local star that is located where? At the what? At the center of the what? Of the solar system. The solar system. So, so the sun is the one, is that local star that's in the center of the solar system. All right. So let me show you all the solar system. How many planets do we have? How many planets do we have? Y'all don't know the planets?
We have 8. And one is extinct.
One is extinct. One is extinct. So what it, well, not extinct, but they call it a dwarf planet. So this is that's Pluto.
This is so small.
Yeah. So this is the sun, right? All right. So this is the sun. The sun is at the center, all right, of the solar system. We can go back. We don't want these. So the sun is at the center, and this is Earth right there. And these are different planets. So the sun is it's a star, interestingly enough, but the sun is a star. All right, the next thing so we need to know that. So the sun is.
So we have like a dome around our planet so that none of the so we could breathe and stuff.
Yes, call it atmosphere. All right. What is the name of the planet that receives the most energy from the sun?
Earth?
What planet? Earth? No, not Earth.
Earth?
No. What planet
Venus?
receives most energy from the sun?
Mars.
Why you say Venus?
Mercury?
Mercury.
Is it Mars?
Yeah, at this point, oh my. Which one receives the most energy from the sun?
Mercury?
Is it Mars?
Mercury.
Venus.
All right, put your answers inside the chat. Put your answers inside the chat. Let me see what it is. All right, the planet that receives the most energy from the sun. All right. And well, maybe I should give you all options, right? I mean, when I say out of these four, which one receives the most energy? Is it Jupiter, Mars, Newton, and Uranus? Out of those four. Out of those four, which one received the most energy? Let's look at the chart, right? So the chart where we have the labeling of it. So y'all could see. Or maybe we could do this one. This is a good picture. So we have this picture right here. And if you look carefully, right, we have the sun. Then right after the sun is what?
Mercury.
Mercury. So Mercury is the closest. Then after Mercury is Venus, right? And after Venus is what?
Earth.
Earth. Then after Earth is what?
Mars.
Mars. So Mars comes before Jupiter. Mars comes before Uranus. Mars comes before Neptune. So the one that has the most out of those four, out of Mars, Jupiter, Uranus, and Neptune is what?
Mars.
Is Mars. Very good.
Mars.
I was right.
Yes, you were.
I said that a lot.
Yes, you did. So Mars is right. Mars, definitely. So Mars, let's write this down. Mars receives the most energy from the sun out of the energy of the sun relative to Jupiter, Neptune, and Uranus. Why is that the case? Because it's what? Because it's what? Closer to the sun. All right. So Mars receives the most because it's closer to the sun. All right. Where is Adaya here? Adaya, are you there? I don't know if she's here. Adaya, can you hear me? 1 second. Is Adaya here? I'm trying to face. So who's this on iPad? Oh, that's Madeline. Madeline's on iPad. Okay. Okay, so
Excuse me.
go ahead. Tajani, I can't hear you.
This Najara.
Go ahead, Najara.
Can anybody breathe on
And
Mars?
no, you can't breathe on Mars unless you have like a spacesuit or something like that. All right, next we have so we want to figure out like, so you have like spacecrafts that sends data back to the Earth to be processed. And what is the name of that spacecraft that sends Earth what's the name of the spacecraft that sends data back to the Earth to be processed? What do we
Is
call
it a satellite?
How are you talking about that?
I don't know.
Is it a Hubble telescope?
Who said that?
Lorenda?
Yeah, that's correct. It is the Hubble telescope. It is. That's correct. So let me show you all the Hubble telescope. This is a huge telescope, right? All right. So it's gonna be Hubble telescope. Let me show you all that. So the Hubble telescope is very important, right here. And they use it to explore, and they use it to like just basically to see deeper into the solar system. All right. And okay, good. Now we have something called a space probe. I don't know if y'all familiar with a space probe. This is a Hubble telescope, but a space probe is another thing that we use, and we use that. I don't know if y'all you see this in like in movies and stuff like that, but let me just show y'all on the on this. So you have this. Go ahead. 1 second. This is what we call a space probe. Let me show you a good. But y'all ever saw these? There's a space probe. Now, space probe.
I think so.
It's a spacecraft, but nobody's on it, right? But we use it to explore the outer space and collect data about, you know, the celestial bodies. So, space probe. This is a nice one as well. It was launched in 1990, and we use this It's a spacecraft, but nobody's on it. So that's why we say it's an unmanned spacecraft. And we use this to collect data about celestial bodies and stuff like that. So the answer is gonna be the space probe. All right. So let me stop sharing my screen now. But the Hubble telescope is also important because we use that as a huge telescope to be able to see stuff. So a space probe, like I just showed you, is an unmanned spacecraft. Let me just say it's a spacecraft. It's a spacecraft to make it simple. It's a spacecraft sent to explore outer space and collect data about celestial bodies. All right. So what do we call a spacecraft that is sent to explore outer space? What we call that?
A space probe.
Space probe. Very good. It's a space probe. Now, okay, good. Now let's move on to question number 4. All right, let's move on to question number 4.
Mr. Petit,
Mhm.
who named the planets?
I don't know who named the planets, I never even thought about that. I guess some scientists, I'm not sure. You can look it up, but I don't know what name them. Tajane, are you speaking? Hello? Can y'all hear her?
No, sir.
Also,
No, I
she might
can't.
turn up her volume.
No, I can't hear her either. Okay, the instrument used to study objects in space is the what? Is it the microscope or the telescope?
The telescope.
Telescope.
The telescope, very good. The telescope. Telescope. So we use the telescope to see things that are far. We use the microscope to see what?
Small
See
thing.
things up close.
See things up close, very good. Okay, to see things up close. All right, so go ahead, Wyatt, and read 1 and 2.
The sun is the local star that is located at the center of the solar system. Mars receives the most energy from sun relative relative to Jupiter, Neptune, and Uranus because it's closer to the sun.
And go ahead, Madeline, read 3 and 4.
A space probe is a spacecraft sent to explore outer space and collect data about
Celestial.
celestial bodies.
Mhm.
The instrument used to study objects in space is the telescope.
Very good. All right. Let's move on to question 5, which is Number 5, right? So,
Excuse me, Mr. T.
mhm,
These don't really look like questions.
you'll see.
Yes, sir.
All right. So if we have something unusual happen in the weather, what do we call that? So an unusual weather disturbance is called a what? It's called a what? So when something bad happen in the weather or atmosphere, what do we call that? Anyone know? Legacy, please turn your camera. Adaya, turn your camera as well. So when something catastrophic happens in the weather, what do we call that? What is that called?
Like a hurricane or something?
A hurricane. Okay, it's a hurricane, but it starts with S.
Storm?
Say it again.
A storm?
A storm. Very good. It's called a storm. So a storm is unusual. It's unusual weather disturbance. Now, if you are in a storm, so let's say a hurricane. So if you are out in the open during a hurricane, anyone ever been in the open during a hurricane? I hope
No,
not.
sir. But
I
my
hope-
auntie has.
All right. If you are out in the,
No,
if you-
sir, I have not.
no, if you are out
Because
in
I am very light and I can get blown away easy.
Well, during the tropical storm, I did went outside. I went outside
you
to
went
do
outside
something.
to do what?
I had to get some stuff.
You had to get some stuff. All right. Okay, good. All right. So, but what should you do if you are outside in a hurricane? What should you do?
Find shelter.
Lie
Find
down.
shelter.
If it's a tornado,
If it's like a bad hurricane or a tornado, you have to find hurricane shelter specifically.
So should you sit in front of your house?
no, sir. You should
No,
go
sir.
outside to be safe. Oh, sir.
Should you stand next to a metal light pole?
No, sir.
Definitely not.
No, sir.
No, no,
If you do, then your
I
line
wanna
is
get
going
head
to start to
concussion.
be going throughout
No.
the earth.
no. Should you
I do not want to get a head concussion.
run under a big tree?
No, sir.
No, sir. That's the worst.
That could be worse
Why?
than a head concussion. That could
Why?
be a body
The
concussion.
tree could trip over and land on
Because
you.
lightning strikes on tall stuff.
All right. Should
Like how
you?
trees land on
When the
people.
lightning strike on the pole, you can get shocked.
All right. So should you lie flat on the ground?
No, sir. Oh, no, sir. Cause no, sir. Cause I remember I forget the article why.
You actually should. They say, I wouldn't
I
recommend
lay
it.
on the ground.
I would actually try to get home. But they saying if you're in an open area during a hurricane, Legacy, what's happening? Are you
What if
fine?
it was a tornado though?
Are you? This is like
I mean,
I go home. I found
like
that
a
funny.
flood. What if it was like a flood?
no. If it's like it in this case, they're talking about like with a lot of wind.
Jeep when it's like a flood, like a tall Jeep?
During a tornado, well, you could drive. You could. I mean, it
During a
depends on the
flood.
category. It depends on the category. Like if it's a category
Excuse
1.
me, Mr. Matee.
1 second. If it's a category 1, it's not that bad. If it's a category 2, then things are starting to get really bad. And 3 and 4, you don't even want to be outside. You want to be in a safe space. In fact, you don't even want to be in that area. But say, for instance, you're in an area with a lot of wind. You definitely don't want to stay in front of your house. You definitely want to be on a metal pole. Definitely don't want to run on a tree. The best option is D. That they have on out of these four when they say lie flat on the ground. That's the best thing to do. Out of these four options that they give us. And the reason why lying flat on the ground is the best option out of the four is because lying flat on the ground would prevent anything from reduce the risk of getting hit by flying debris. So if you standing up, then you can get hit. The likelihood of you getting hit is higher, but if you lying flat on the ground, then they can fly over you. That's the idea. All right.
Mrs. Batty, would you still, and you wouldn't, and likely most you wouldn't get struck by lightning, right? What about like the shot?
Okay, so that's number 6. Now, next question. So when rocks, write this down. When rocks are weathered, and eroded, water, ice, or gravity moves the weathered material from the rocks and deposits them in other places. This process is known as what? So okay, this process is known as what? So what do we call this? They give us 4 options. Is it an earthquake? Is it wave action? Is it movement? Or is it deposition? Right? Which one is it? Or deposition, right? The process where when you have weathered rocks, when rocks are weathered, and by the way, let me show you what I mean by weathered, because you might not know. You all know what I mean when I say something is weathered?
Yes, sir.
What does we
No,
mean
sir.
by, if something is weathered, that means, is it old or is it new? Or is it beat
It's
down?
old. It gets older gradually over time.
Yeah,
It's old and beat.
yeah, it's beat down, and like the wind and water has affected it, right? That's what I mean by weathering, right? But when those weathered rocks or weathered material are deposited in other places, what do we call that? Is that an earthquake? Is that movement? Is that wave action? Or is that deposition?
Deposition.
Yes, it's definitely deposition. So DEP.
OSITION.
Very good, deposition, okay?
Excuse me, Miss Petit.
So it makes sense because that's when they are deposited, or that's when they are placed in other places when they already finished weathering. So that's that.
Excuse me, Miss Petit.
Go ahead.
Yesterday I came first in my school spelling bee.
You came, what school is it?
Morristown Primary.
Morristown Primary. That is excellent. Keep up the good work, young man. Keep up the good work.
Yes, sir.
I'll
try.
By God's grace. That's good. All right, so next. Adaya, can you read number 7?
When rocks are weathered and eroded, water
Eroded.
water and ice or gravity moves the weathered material from the rocks and deposits them in other places. This process is known as deposition.
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 Very good. All right, next. So let's move on. from this scope. Then we talk about the telescope and everything. Where's Trinity? Trinity, are you there? Trinity, can you hear me? Is Trinity here?
Yes, sir.
Okay, are you writing this down?
Yes, sir.
Okay. Where's Kylie? Is she with you?
Yes, sir.
Okay. All right, so let's say that we have a student. So if a student, let's say if a student wants to compare the mass of a golf ball and a tennis ball, the student should use what? So, by the way, what you think is heavier? Is it the golf ball or is it the tennis ball? Which one is heavier? What do you think?
Golf ball.
The golf ball?
Tennis,
They
no, golf,
make tennis.
Which one is gonna be heavier?
golf ball. Golf ball.
Golf ball?
I'm not sure.
Yes, sir.
Golf or tennis?
Go.
Golf. Definitely the golf one would be heavier, right? So,
Yes, sir.
so if they wanna measure or if they wanna see which one is heavier, what instrument should they use? Now, let me show you the options, right? So you're gonna tell me which instrument should they use. I'm gonna, I'm show you the picture of it and you can tell me which one you think you should pick. All right, so let me show you. This one you actually gotta see the diagram. So there we go. So we have these 4 options, okay? Which one should they use if they're trying to figure out, they're trying to figure out, or they're trying to compare the golf balls, what instrument should they use?
B.
Say it again.
B the weight, the
B.
waiter, or the
B.
scale.
B.
All right, B. All right, what do we call A? A is what?
A ruler.
A is a ruler.
Ah,
A is a ruler. What do we call C?
Meter.
C is a
Mm.
cylinder. C is a cylinder. C is a cylinder. All right, what do we call D?
Microscope.
Microscope, very good. And what do we call B?
A scale,
It's a scale. It's a balance scale,
scale.
right?
balance scale.
Balance scale, yeah. And so we use that to compare the weights. So if we want to compare the weight of a golf ball and a tennis ball, what do we use?
Excuse me, Mr. Matisse.
Weight, we
Very
would
good.
use a scale, and if you want to check the size, you use a ruler.
Yeah. So we also call they also call also known as, we could say also known as a triple beam balance. That's also another way to call it too. Triple beam balance. So both of them are the same name. So balance scale or triple beam balance, both of them are the same thing. Okay,
Excuse me, Mr. Matisse.
go ahead.
When you have if a student wants to compare the mass of golf ball, is it supposed to be of a golf ball?
Yes, of a golf ball and a tennis ball. Right, they use a balance scale or triple beam balance. Okay, good. Now what if we want to find the volume of, let me change this and just move this and then this and then this. All right. So if we want to find the volume, so if a student wants to find the volume of baking soda.
Yes, Mr. Potato.
Go ahead.
Can I ask my mother something real quick?
Yes, you can. If the student wants to find the volume of baking soda, what instrument should they use? Now, again, we're talking about volume, all right? So for volume, let's go back to the picture. Let me go back to this picture. So we're going back to this picture. And again, we're trying to find the volume. All right. So if the student want to find the volume, right?
Mr. T, what is volume?
Volume is the amount of a substance. So for example, like how much of that substance do you have, right? That's what we mean by volume. So the amount that you are able to fit in a particular container, basically, all right? So basically the volume is the amount of space that a 3D object occupies, the amount of space that it takes up. So volume is different than area, right? Area is the amount of space that a 2D shape occupies. But volume is the amount of space an object occupies. So it's three-dimensional. You can use it for solid, you can use it for liquid, or you can use it for gas.
I have a question, Mr. Whitfield.
Go ahead.
Does the cylinder have like labels on?
A cylinder does have a label. It does have a label. So which one do you think we're gonna use to find the volume?
Excuse me, Mr. T.
Uh-huh. Go ahead. Go ahead. I can't arrow. What are we gonna use to find the volume of baking soda? We're gonna use.
C.
What are we gonna use? Madeline, what are we gonna use?
C.
C, very good. Because the ruler is for length. The balance is for weight or
I'd
mass.
probably use a ruler.
Why would you use a ruler? You're trying to find the volume. You're not trying to measure length. Like how much baking soda do you have? So it's kind of like a measuring, it's kind of like a measuring cup in a way. So the answer is going to be definitely B. Graduated.
You mean C, Mr. Petit?
Yeah,
What is C?
C is a cylinder.
Oh, all
Yeah.
right.
So a graduated cylinder would be used for finding the volume. You can't use a ruler. You can't use a thermometer. Thermometer is for temperature. All right. So, right. Let me just show you all a real example of it. All right. That's a real example of it. This is an actual real example of a measuring cylinder.
Oh, that's
Yeah.
what it is.
Yeah.
I've seen that before, I
Yeah.
think.
Trinity, please do not write on my screen.
We learned about this. Well, we saw a little diagram of this today in class.
You mean of the measuring cylinder?
Yes, sir.
That's excellent. That's very good. Very good. Now let's move on. Has anyone ever? Has anyone ever? Yes, you can quickly. So, Lincoln, you have to go, or you already left? I think you're already gone. All right. Okay. Now we have. Now we have Kong salad. Has anyone ever eaten Kong salad before?
I wish I could eat it every week.
I have.
You have. All right. So tropical Kong salad. Tropical Kong salad.
Yes, Mr. Petit.
Oh, I can hear you now. Very good. Is made up. What did you change? A combination of conch and several different vegetables and fruits. when this is produced, when this, okay, we could say a conch salad. Okay, when,
Yes, Miss Pati.
go ahead, please.
Can you hear me now?
Yes, I can. Yes, I can.
I don't
Would,
think my camera working.
okay, I could hear you. These ingredients combined form what? So when you have a conch salad, let me just show you all.
Excuse me, Miss Pati.
Go ahead.
I'm gonna have to leave a little bit early today.
Okay, that's no problem. So when you have conch salad, right? Which in, it looks like this. So when you have conch salad, when you have conch salad, what is this? Is this a element? Is this a molecule? Is this a solution or is this a mixture? What is this?
Mixture.
A mixture.
A mixture.
Are
Very
you
good.
saying about
Most definitely a mixture.
Very good. Very good. So these ingredients combined form a mixture. A mixture. Go ahead, Adaya, read number 10.
Tropical conch salad is made up of a combination of conch and several different vegetables and fruits. These ingredients combined form a mixture.
Very good. I'm gonna show you all something that y'all never seen before. Let me see. Let me see. Let me show you something that you've never seen before. Has anyone ever seen this before?
I've
Yes,
seen
sir.
that
I
so much
have.
time.
Have you seen
I'm
this
just
before?
kidding.
so that at my school?
Okay. All right.
Is that lemon water?
So this right here is what we call switcher. Now switcher is made up of what?
I've heard of that.
It's
Lemon?
made up of what?
Water,
Lime and what?
water,
Lime and water, right? So
Oh yeah, I've seen that before. I've seen that before.
and also sugar, right? So Ashley,
It's a little bit sour and sweet.
sour and sweet at the same time. So switcher, which is made of lime, right? Sugar and water is a solution. Okay. What the name we say that the water is the solvent, and we say that the sugar is the what? Is the solute. So there's two things, right? Whenever you have like a mixed solution, the water is a universal solvent. So the water does the dissolving. So yes, Trinity. Or Kylie. Kylie. Go ahead.
Kylie went she went home.
Okay, no problem. So when you have, what happened to your camera? Trinity, turn on your camera. 'Cause I can't
Excuse
see.
me.
Yes, Adaya.
The switcher bottle blocking the pathway is.
Oh, okay, so you can't, okay, no problem. So, good. So the switcher or the lime and water, or the lime, sugar and water, we call that a solution, right? Now, solution has two parts, the solute and the solvent, okay? The solute is what is being dissolved, and the solvent is what does the dissolving, right? So in the case of this lime and water, Trinity, your camera is off. I don't know why you turn it off. In the case of in the case of lime and water, right? The sugar, right, is the solute. The sugar is the solute. So the sugar is the stuff that's going to be dissolved inside of it. Okay, the sugar. And the water is the solvent. Y'all understand that? So the sugar is the what? What's the sugar?
The sugar is the solute.
The sugar is the solute. Very good.
It's dissolved.
The sugar
I've learned about this before.
excellent. Very good. And the water is the what? And the water is the solvent. Very good. The water is the solvent. So the sugar is the solute and the water is the solvent. All right, does that make sense?
Yes, sir.
Good. So Wyatt, what is the solute? What is the solute?
Sugar.
Wyatt, what is the solute? What is the solute?
Sugar and water.
No, the solute is the sugar, right? The solute is the sugar. What is the solvent? Wyatt?
Sugar and water.
No. The solvent is the water. So let's try it again. Wyatt, what is the solute?
Sugar.
The sugar. What is the solvent?
Water.
The water. Very good. So the sugar is the solute and the water is the solvent. Madeline, what is the solute?
The sugar.
What is the solvent?
The water.
Very good. And Adaya, what is the solute?
The solute is sugar.
And what is the solvent?
Water.
The water. Trinity, what is the solute? Trinity, what is the solute?
Water.
What is the solute?
Sugar.
The sugar. What is the solvent?
Water.
The water. Very good. So the solute is going to be the stuff that is being dissolved. And then the solvent is the thing that does the dissolving. Okay. Now let's move on to energy. So you have different forms of energy. You have potential energy, and you also have kinetic energy. Potential energy is energy that is stored, right? Potential energy is energy that is stored, right? Energy that is stored. Then you have kinetic energy is energy that is energy that happens when something is moving, right? So potential energy is stored energy. Kinetic energy is energy that results from movement, right? Movement. So potential energy, let's write this down. Potential energy in a ball becomes kinetic energy, when the ball rolls down a hill. Now, why is that? The reason why the potential energy in a ball turn into kinetic energy when the ball rolls is because, remember, kinetic energy is energy that happens when we have movement, right?
So
When
it's
we're moving.
motion.
Yeah, energy that is result of motion or movement, all right? Potential energy, let's say, for example, the ball is on top of the hill. If the ball is on top of the hill, we say that that ball has a lot of potential. So we say that if it's on top of the hill, we say that ball has a lot of potential. Okay, so it has a lot of potential. This ball has a lot of potential. But once it starts rolling down the hill, it's no longer potential. It's actually what? Kinetic energy.
Kinetic.
Yeah. Kinetic energy. All right. So on top of the hill, potential. When it start to roll or when it start to move, it is kinetic. All right. Legacy, read. Go ahead. Tajana, you have a question?
So potential is basically where it's still, and kinetic is when it's moving.
Exactly. That's exactly right. That's exactly right. Okay. All right. So, so if we have, let me show y'all something. Y'all might have seen this. Y'all might have seen this in, maybe some of y'all have this in your house or not. If you do, it is really nice. But I'm gonna show y'all this and y'all gonna tell me if y'all ever seen it before in real life. Okay, so let's go ahead and see this. All right, has anyone ever seen this before in real life?
I have. Those are solar panels.
That's
Exactly.
a solar.
Yes, sir.
Yes. What do we call this?
Solar panels.
Solar
Solar
panels.
panels.
Solar panels, right? So solar panels. Now, solar panels, where do solar panels get their energy from?
The sun.
The sun.
The sun.
The sun.
The
Very
sun.
good. The sun. So solar panels is powered by light energy, right? That's the source of energy that it gets from. Same thing. Anyone ever had a solar or saw a solar calculator? They also have a solar calculator too.
Yes, sir.
No,
I
sir.
own
I
one.
have
I own
that.
one.
Yeah. So solar panels. By the way, y'all finish? What numbers y'all finish? So I could move them because we need space.
I own number 13.
I'm on number 8.
We're number 8.
I own
Anyone
number 13.
number 13. Anyone on number 7?
I'm number 7.
Who's on number 7?
Trinity.
Trinity, let me move this then. Okay, so this would be number, I think this is number 7 now. Yeah, good. So this would be number 7. Let me move this. This is number 7. Then number 8. Then number 9. Then number 10. Then number 11. Number 12. Then number 13. Okay, so solar panels, solar powered calculators, and space probes use the same energy, which is what? What type of energy do solar panels stop?
Radiant.
What sort of energy is that?
Radiant.
Is it electrical energy, light energy, mechanical energy, or sound energy?
Light.
Light energy, very good, light energy. So the type of energy that powers or that provides energy for solar panels, solar powered calculators, and space probes is what we call light energy. All right. Go ahead, Legacy, read number 13.
Solar panels. Solar power calculators and space probes use the same energy, which is light energy.
Very good, which is light energy. All right, move forward. Let's move on to number 14. How many persons would like solar panels when they grow up?
I would. I'd pay all the money that I would pay for my power bills one time.
Anyone else would like solar panels? on
I have something like them
yes.
because
Uh-huh.
when power is off, we use that to charge stuff.
You use okay. So in order for electric charge to flow, so in order for an electric charge to flow, a circuit is needed. Now let me show you what is a circuit. So a circuit is going to be like this is an example of a simple circuit. So you have a battery. Let me show you all them. So you have a battery. It's a simple circuit, right? So you have a battery, right? You have wires. You have a switch. You have the light. This is what we call a circuit. What do we call this, class? What is this called?
A circuit.
A circuit.
A circuit. And electricity is going to pass in this circuit. All right. Electricity is going to pass in this circuit. And electricity or electric charge is not going to flow if you don't have a circuit. So in order for an electric charge to flow, a circuit is needed. All right. So Lorenda, in order for electric charge to flow, what is needed? Where's Lorenda? Is Lorenda here? Oh, she had to leave early. Okay. Adaya, in order for electric charge to flow, what is needed?
A circuit.
A circuit is needed. Did you see the circuit that I had on the screen?
No, sir.
Okay, let me show it again. This is a circuit.
Yes, sir.
This is a circuit. So you need the circuit in order for the electric charge to flow. All right. Now, let's move on to the next one. So now, now we're talking about electricity.
Excuse me, Spotty.
Go ahead.
She said she's gonna leave and join back.
Okay, no problem. Now, thank you. Now, the next thing is you have insulators and you have conductors. Okay. So insulators are stuff that doesn't conduct heat and electricity very well. And a conductor is something that conducts electricity very well. So what do I mean by that? If you have plastic, if you have wood, if you have rubber, those are not good conductors of electricity. What does that mean? That means that if you notice, let me show you a spoon, right? If you notice the handle of a spoon, right? A cooking spoon, right? If you look at the cooking spoon, this is a good example of it. If you look at the cooking spoon, you notice that the handle is made out of what? What is this handle made of? What is this?
Plastic.
Okay, plastic, right? Now, is the whole thing steel? Like,
No, sir.
is the whole thing? Why don't you have the whole thing is steel?
Excuse me, Miss
Because if
Boutique.
the whole thing was steel, then when you put the spoon in the pot, the heat will travel up the spoon and burn you.
Exactly. All right. So, Lorenda, can you hear me?
I can hear you now. I couldn't hear you then.
Okay, good. So the whole thing, if we look at this, right? Let me put this on the side. So the whole thing is not right? Is not steel. The whole thing is, so you have part of it that's sort of a metal, right? A good conductor, and then you have part of it that is like rubber or plastic. Now, why do we need this rubber on the handle portion? Why do we need it?
Just in case, like, the metal pot hot, so it won't burn you.
Exactly.
So you don't get burnt.
Exactly. So you won't get burnt. We call rubber we call plastic, we call wood, all of them are what we call insulators. What do we call them, class?
Insulators.
Insulators.
Insulators, very good. We call them insulators. Now, insulators mean that they're not gonna easily get hot. They're not gonna easily conduct electricity, right? So it's a good thing. Now, the steel part gets hot very fast. That's because it is a good conductor of electricity. All right, and so what that means is that if we're looking for a good conductor of electricity, it's definitely going to be steel. So steel, aluminum, copper wire. So wires, right? Wires are good conductors of electricity. Wires are good conductors of electricity, especially like copper wires in particular are good conductors of electricity. All right, they are good conductors of electricity. That means that if you are being that means that if you're being electrocuted, you don't want to, I hope, hopefully you don't get electrocuted, but that means that in order for you to have electricity flowing, you need copper wires or you need some sort of metal that will make it flow faster.
I
Right.
get like shocked on the trampolines. Like if it's hot, if the sun's out, or if I'm on it and I'm jumping and I touch
Yes.
somebody else, I get shocked.
Yeah.
And I got shocked by an actual coin.
Wow. Go ahead.
So basically, I think that's what you're saying. So, like, if he touched a metal spoon, that's electricity.
No. If he touch a metal spoon, it's gonna heat faster, as opposed to if it hit, like, if you imagine if anyone have like a wooden spoon, if you have a wooden spoon, like you could stir, and say you're making noodles, you could stir the pot and it's not gonna be heated. Like it's not gonna be, you still could hold the spoon because the spoon is not gonna get hot, right? But if you had a completely metal spoon and you holding that over the fire, the metal spoon is gonna get hot very fast. That's because the metal spoon is a good conductor of heat. The same thing with electricity. If you have a metal wire, the electricity could pass through it fast. If you have a rubber wire, in an happening, the electricity is not gonna pass through that. All right. So that's why you notice that the wires are covered in rubber, right? So that you wouldn't get electrocuted when you touch the wire. All right. Does that make sense?
Yes, sir.
All right.
Yes, sir.
So
Sir.
if we have, so let's talk about magnets, right? So if you have magnets, you have so magnets, you find them on your fridge, you find them on, especially when with the fridge
In
with
the
those,
garbage.
you could find magnets. You even buy magnets, right? So
I thought you said maggots.
no, magnets. Magnets. So so what happened with the magnets? So with magnets, opposite. So let's say, right, we have if a student, let's say her name is Jessica, right? If a student take one magnet, if a student takes one magnet,
Excuse me, Miss Pretty.
yes,
I don't know what's going on with my tablet, but I just can't hear you. So I just writing down the notes.
okay, I can hear you though. That's good. If a
Yes, sir.
student takes one magnet and turn it to the North Pole, and take another magnet and turn it to the South Pole, the magnets would do what to each other? The magnets would what? would they push away? Would they not move? Would they attract or would they repel? What would the magnets do? You have the North Pole, you have the South Pole. What would they do if you put them together? Right? Do y'all know?
I'm guessing that they would
They would what?
push away from each other.
You think they would push away?
Attract.
Who said attract?
Why?
Wyatt, very good. They would attract.
Excuse
So
me,
let me
Mr. T.
go ahead, Dajane.
When you have on number 16, it says, if one student takes one magnet and turned it to the North Pole and take, is it supposed to be took or just put take?
And takes another magnet. So let me show you what I mean. So if you notice that this magnet, right? So we have these two magnets. In the first picture, let me put this on this side so y'all could still have your notes. And then just move this. And all right, so let me put this over here. Right? So in the first picture, so that's, let me enlarge this some more. So in the first picture, we have the North Pole and we have the South Pole. And when we have the North Pole and the South Pole, because they are opposite poles, they're going to attract. So for magnets, opposite poles attract. Okay. And then if we have the same poles, are they going to come together? Like the S and the S. Are they going to come together? The answer is no. So like poles do not come together, only opposite poles. So north and south is going to come together, they're going to attract. But south and south is not going to attract. All right, does that make sense to y'all? Let me know. Does that make sense?
Yeah, so that makes sense because I was trying to put two magnets together before and they kept on pushing away from each other. And I was like, why is that? And then I said one might be
One might be, they might be the same poles, right?
that's kind of yes, sir.
Yeah. So if they're the same poles, then they're not going to attract. Only opposite is going to attract. So north and south is going to attract. South and south is not going to attract. North and north is not going to attract either. Okay, that's number 16. Let's go ahead and do another one, number 17. Magnets attract magnetic materials such as metals and what else? So even paper clips, right? Let's say, yeah. So a magnet can attract paper clips. So if you have a magnet and you put it over paper clips, the magnet would the paper clips would like attach to the magnet. All right, so that's very important to note. And then
I've done that before. I put a magnet over some
somewhat.
But I put a magnet over some paper clips before.
Okay, that's excellent. So if we want to conserve energy at home, what should we do? So if we want to conserve energy, conserve energy from home, we have to leave the lights on. Is that true?
No, sir. You can change the you can change put solar panels on the roof.
Or we could unplug appliances when not in use. So if we ain't using it, don't leave it on. So if you're not using the fan, don't leave the fan on. Anytime anyone parent to say, don't leave the fan on, Turn the light off. Any of your parents to say that?
All the
A
time.
lot.
A lot.
All the
A lot. A lot. Yes.
What a financial drain.
Trinity, turn your camera. Kylie, turn your camera. Adaya, turn your camera. Wyatt, turn your camera. All right. So if we want to conserve energy, you have to unplug the devices if you're not using them. So if you're not using it, you have to unplug it. All right. Otherwise, you're wasting energy. Next.
Excuse me, Mr. T.
Uh-huh.
If you leave the fridge open, is that also wasting energy?
No. That's not wasting energy because it's you still using it. Because you have stuff inside of the fridge, like
Yes.
that needs to keep cool. If it doesn't keep cool, then it would
Technically, it's not wasted energy. It's more like raising the power bill.
yeah. Well, that brings us to the next point. What does the term what do we mean by conservation of energy? So, conservation of energy, conservation of energy is the careless and so I say it's the unwise and careless use of energy. So yes, you're right. The power bill will go up, but the reason why we try to conserve energy is because we don't want to use energy in an unwise way, right? That's what we mean by conservation of energy. You're trying to conserve it because how do we get energy? You got to get energy from the sun. You got to get energy from fossil fuels. And if you're getting energy from fossil fuels, that's not forever, right? That's not forever. There's one day we will run out of fossil fuels, right? So if that's the case, then we have to conserve the energy, make sure that we use it in a wise way, because in order to get it, it takes a lot to get it. So we have to make sure that we use it wisely. That's what I
But
mean
the
by
sun will never go out.
yeah, the sun will never go out. So that's why solar and we call that renewable form of energy, right? Because it's continuous. But non-renewable forms of energy, like fossil fuels, they are limited. And if once they run out, that's it. All right. So then you can't use fossil fuels no more. You have to use something else, like oil. So oil, coal, those are non-renewable sources of energy, and they hurt the environment. But they are what we use a lot in the Bahamas, especially in the Bahamas. We rely a lot on fossil fuels burning. And so with understanding that we get our energy from fossil fuels being burnt, you don't want to use it in a careless way. You want to use it in a wise way and conserve it so that we could be able to help everyone to understand that you don't want to waste stuff. All right, so anyone finish with the notes before we
I'm finished with the notes.
finish with the
I
notes?
finished with the note.
Finish with the notes, okay, good. If you're finished with the notes, take a picture of it and send it to me via WhatsApp again. If you're finished with the notes, take a picture of it and oh my goodness, it's the wait. There's a correction that needs to be made. Conservation of energy is the not the unwise, it's the wise and careful use. And careful. I don't know why I say unwise. So conservation of energy is the wise and careful use of energy. Please correct that. So when you use energy in the right way and use it carefully, that is conservation of energy. So make sure I correct that for me. Do you hear me, Lorenda? Not Lorenda. Najara, correct that before you send the last one. So the careful and wise use of energy. All right. The careful and wise use of energy. All right. That's what I mean by conservation of energy.
I sent my work to you, Mr. Boutique.
I also sent my work.
Excuse me, Mr. Petit.
Hello? Yes.
Um, when we finish our notes, is there anything else for us to write?
No, we have to do a quiz.
Okay.
So it's not okay. It's either yes or no, sir. Adaya. So let's go ahead and do the quiz. Okay. So okay, let me go ahead and so you need to try to get full marks. That's what you want to do. Try to get 19 out of 19. Who all have finished sending their work? Let me know, please, if you already sent in your work.
I have sent in my work already.
Excellent.
I have sent in my work.
All right, good. All
I
right.
sent my work.
All right. So for those of you who are writing, I mean, for those of you who are finished with writing, take a picture of your work and send to me, and then you can start the quiz. If you are still writing, Trinity, I know you're still writing, but I need you to pause your writing and I need you to do the quiz. All right, so pause your writing and do the quiz. And then you can always get the notes and write them later. But pause your writing and do the
Yes,
quiz.
sir.
All right. Try to get as much as you can correct. You're trying to get 100% on this. Make sure I do that for me. Madeline, please redo it. Tajane, what number you on?
Excuse me, Mr. Petit.
Mm-hmm.
For number 7, it didn't take my answer.
No, number 7 is does not count.
Oh.
Excuse me, Mr. Petit.
Mm-hmm.
My daddy asks, when does the class end?
We end when, so your exam is like May. So we continue up until it's time for your exam. So like in May, June,
No, he mean like for this class.
we end at 6 o'clock.
Okay. Yes, sir.
What number you on now?
I doing the quiz.
What number you on?
On the quiz?
Hmm?
Number 4.
Okay.
Excuse me, Mr. Petit, I got a 19 or 19 on my test.
Yes, I saw it. Have a wonderful evening.
Wait,
Excuse me, Mr. Petit.
Go ahead.
I got everything correct.
Yes, 19 out of 19. Very good. Trinity, please redo your quiz. Tajane, please redo your quiz.
I
Excuse-
finished my quiz,
excuse me,
Mr. Petit. I got all right.
Go ahead, Adaya.
My auntie, her niece, well, my auntie told me to say that her niece might join the class, so she told me that to send her your number.
Okay, do you know my number?
Yes, sir, I have your number added.
What grade is your niece in?
My cousin, she in grade 6.
She's in grade 6 as well. Okay, that's no problem.
Excuse me, Mr. Petit.
Yes. Yes, Najara.
I finished all my
You
stuff.
finished?
Yes, sir.
You got
I
19
got
out of
it
19.
right.
Very good. I
Yes.
saw it. Excellent job.
Excuse me, Mr. Petit.
Go ahead, Tajani.
I missed the question.
Yes, I see it. 17.
Miss Petit, did you want me to send you my grade?
No, I got it.
Oh,
You know, you still could send it. Still send it. Still send it.
yes, sir.
Still send it. Legacy.
Do you want me to leave now?
You could leave now. Once you finish that, you could leave.
Thank you for teaching me today.
Thank you as well. Have a good night. Have a good afternoon. Good evening, rather.
Good evening.
Wyatt, what number you on?
15.
Number 15. Okay.
Excuse me, Mr. Petit, I got a 19 out of 19.
Very good. Good stuff. Oh, wow. It's already 6:01. I have to leave. Have a good night, everyone.
Goodbye, Mr. Petit.
Good night. Adai, you have to redo your quiz.
Yes, sir.
Thank you for teaching us tonight, Mr. Petit.
You too. Adaya, please redo your quiz and then send a screenshot of your grade to me.
Yes, sir.